Hey, how's it going, everyone? Today, I wanted to take some time to just talk through AWS. Here at Validia, we started using AWS over a year ago. And when you're starting a startup, there's a lot of things that you can find in the AWS platform. When we first started, we were working with some of the rudimentary things that everyone knows about EC2, S3. However, I think as we've gotten more experience building out our service here on AWS, we've learned a lot of new features and things that may be helpful to other startups. And so this is all a part of a series we'll be doing on tools and tricks that we've learned while starting a tech startup and how we've actually implemented that in practice. So with that being said, we can go ahead and jump right in. Looking here at the AWS dashboard, when you first log into AWS, there are a lot of different things that you're going to find. When you go to search up services, pretty much anything that you could possibly imagine will appear there. So when people are getting started with AWS, generally what we're seeing is use of EC2 servers. Now EC2 servers, which is what we're looking at here, are instances that are dedicated for you. They're like a real server, except you access them through the cloud, and you're able to put different operating systems on them. So, for example, let's say you wanted to spin up an API server. Well, you could jump over here, launch an instance in a specific region. We could say name this test API server. And then you have the option to choose the actual operating system that's going to be used on this server. So you can choose Mac, Amazon Linux, which is built by Amazon, Ubuntu, Windows, as well as many others. You can also search through a catalog that AWS offers. So, for example, there are NVIDIA options that have the ability to set up access for a GPU. So things like NVIDIA SMI, PyTorch, or CUDA. So this is just a few of the options here you have right off the bat. Separately, you can obviously choose the architecture. Traditionally, I stick to x86, especially when using Ubuntu or Linux, because it ends up working the best and is the standard. Finally, the next really important piece is choosing your instance type. Now, when you're first getting started with AWS, you've got free tier, which gives you the ability to use certain smaller servers, things like for testing deployments out or actually getting a feel for how AWS works. But then there's a lot of other options here, and they're all priced based on the number of CPUs or the number of memory. So if you scroll through here, you'll see that there's some smaller ones that are a lot cheaper. But as you start to scale up, you'll see you get the C level, which are very CPU optimized. You'll also reach the G level here. If I actually look this up here, G4. These are GPU optimized, but lower level or lower tier GPU optimized. There's the P options as well, which are very powerful GPUs. So things like the NVIDIA A100 GPU. These are traditionally very expensive. As you can see here, Ubuntu pricing is $32 an hour, which if you're leaving this running all the time can scale up very quickly. But this server has 96 virtual CPUs, a very powerful GPU, and a lot of memory to work with. After you choose your type here, you're able to jump down, set up a way to log in or sign in via SSH so you can create a key pair for easily connecting. You can also configure all of your network settings. Now, when working in AWS, networking is incredibly important, especially from a security perspective. AWS, while it is complex, offers numerous different ways to make it so you have a very secure server or your server can only interact with other things in your environment. So it's important to take a look at this. When you're first getting started, the default settings are great. For example, right now, when you first spin up an EC2 server, the only port that is open is going to be SSH traffic or port 22. However, you also have the ability to easily configure HTTPS and HTTP traffic if you're spinning up a web server or an API. You can also choose from existing security groups you've created. So if you've created another server and you want to just use that security group, you can instantly port that over as well. Finally, there's the option for storage as well, where you can configure how much storage your server will have. Now, EC2 is great. EC2 is a great tool for spinning up an API server, web server, and it's actually what we started out with. However, one of the downfalls of EC2 is that it's a server that's always running. It's not super easy to configure auto scaling, at least as much on other services. And like I said, it's going to be constantly running if you have it going, and it's going to run at that consistent rate that you set it. So one of the things that we found actually when we were trying to figure out how to optimize our architecture is ECR and ECS. So ECR stands for Elastic Container Registry. Now, the Elastic Container Registry gives you the ability to create repositories or essentially Docker containers that you're able to store up in AWS and then reference when you're spinning up a server or what is called an ECS cluster. So what you can do is you can easily, via the AWS command line interface, sign into Amazon ECR and then instantly be able to push up repositories or Docker images directly to this ECR service. And like I said, once you have it up there in the ECR, you can use that to deploy on Amazon SageMaker AI, which I'll show you guys, as well as deploy on ECS. Now, what is ECS? So if we look this up here, ECS is the Elastic Container Service. So what this is a secure, reliable, and scalable way to run containers. So let's say, for example, instead of hosting your API on a static EC2 server that has a static CPU load or CPU number, what you're able to do actually is take that API, containerize it, and then deploy it on ECS. Now, when you deploy it on ECS, there's a few different things here. The first thing you do is you create a task definition. So a task definition is effectively what you want to run. What's great about ECS clusters is they're only going to be running, you can at least specify them to only be running when someone calls them. You can specify a certain amount or certain processing power to be running at any given time and have that auto scale upwards as you get more usage. So jumping over to create a task definition here, there are two different options for infrastructure. For one, you can use the Amazon EC2 instances actually with ECS, or you can actually just use AWS Fargate, which is serverless compute. I prefer Fargate because it's much easier to work with. It's cheaper in my opinion, or at least for some of the use cases that we've built for as well. So you have a lot of options when looking at ECS, a lot more than the EC2 side of things. You can choose obviously the operating system, the network, the number of CPUs that your task requires, the memory. Of course, you can also apply roles across this as well. If you're not familiar with AWS, roles are a really big thing, and I highly recommend that you take some time to learn AWS roles or IAM roles before you get started with AWS. But jumping down here, this is where the real magic begins. You're able to specify containers, so you can give that a name, specify the ECR repository URL or URI here where you've added your container, and then you can start to do all the fun things configuring how your container will work. So what will be revealed? So right now it looks like port 80, and then you can set up, for example, port HTTPS for secure transmission as well. You can also start to set resource allocation limits. So this is specific to this task, how much resources are allowed for it, how much should be segmented out for it as well. So now going down here, you can configure all of your logging. One thing I have to say about AWS ECS is that it does a really, really good job of configuring logging by default. When I was first getting started with ECS, it made it super, super easy for me to find all of the logs for my task, for my clusters, and see what was actually going wrong in any case of deployment. And don't get me wrong, when you're starting out working with ECS, you're going to run into numerous issues. I hope you don't, but if you do, there are A, numerous resources, and B, the logging is phenomenal for ECS task definitions. Now, you have a ton of other settings here. Health check gives you the ability to basically specify what defines your container or your service is running. Restart policies, the container network settings, any timeouts. So there's a lot that you can work with here. Finally, you can add some storage, some monitoring, and tags. Again, a lot of the defaults for AWS are pretty standard and work really well. But again, as you start to scale up and use these tools more, I'd recommend taking a look at them. Now, once you have a task definition created, what you can do is you can actually create a cluster. So you can effectively create a cluster here. What this does is it groups together tasks and services so that there is a shared capacity and all of your tasks and services can effectively run on this cluster. Now, the best thing about ECS clusters is they can be built to be auto-scalable. So to give you an example from our own environment, what we ended up doing actually is we had a WebSocket service, video and audio, for handling calls or handling video and audio streams from video conferencing calls. Our technology, we build a bot and it sends us video and audio. Now, we had this running on an EC2 server before, but the problem we ran into is that when there were a lot of people using that and a lot of calls going on, that we were not scaling properly. Our servers were being overloaded and it was going a lot slower than we would have liked to. Now with ECS, what you can do is you can set a minimum running level for the cluster effectively. What this is, for example, you'll have two CPUs running at any given time, which maybe can account for one task's worth. So maybe one video conferencing call. But then as CPU usage goes up or as memory usage goes up, you can start to allocate more and allocate down once that usage stops. So greeting clusters and setting up auto scaling, very powerful tool and highly recommended, especially as you get more use with containers, with EC2, and start to kind of surpass that EC2 deployment. Now, separately as well, going back to the ECR side of things, one of my favorite tools on AWS for our AI use cases is Amazon SageMaker. Now, SageMaker AI provides the ability for you to deploy some of your own custom models. They have models that are already built out in their collection of models as well. And it makes it very seamless for you to deploy effectively AI endpoints or AI API endpoints. What this looks like, if we jump over here, is you have the ability to effectively create, register, and deploy models. So let's see, for example, what registering one looks like. For one, you can use any of the things in the jumpstart, but I prefer bring your own model because we build a lot of our own models at Validia. What you can do is take in model weights or any of your model, store it in S3, AWS S3 storage, and provide the URI here. And then you can provide an ECR container URI as well. That is the Docker container that runs your AI model. Usually you can set this depending or approve depending on if it is ready for deployment or not. You give it a name, and then you have your model. Then what you can do is you can actually start to deploy these models. So you can click on deploy, and you can actually put this on a EC2 server and start running this for your customers or for your internal product. And deployment is super easy. You can choose an instance type that works for you, whether it be a P instance, which are the A100 GPUs, the G instance, which are lower level GPUs. And you can also set this to auto scale as well. So set an initial instance count as well as a maximum instance count. Now, once this is deployed, you can start calling this like a normal API endpoint. There's a lot of documentation on this, and I'm happy to provide some in the comments or in the caption as well. But all of this is to say that AWS has a lot of features that we've found really cool. SageMaker, ECS, and ECR being some of our favorites. One other that I'll actually jump back over to that I'm a fan of and something that we have not quite worked with yet, but we're looking forward to, is AWS Lambda functions. If you jump over to Lambda, if I can find this here, Lambda functions are serverless functions that effectively operate each as a standalone API endpoint. So what you can do is the ideal, at least in the API world, when you're deploying on AWS, is to have every API endpoint be a separate Lambda function. They're all serverless. They're all only running or being called when someone actually calls them, which means you're not really paying for compute when someone's not using the API or using certain endpoints. So Lambda is super, super powerful. We have not made this move over yet, but we're really looking forward to doing so. Now, again, all of this is to say AWS has a lot of awesome features. I know this is a very high-level overview, but we wanted to give an introduction to some of the stuff that we've found fascinating about AWS and some of the things that we've been looking at. And hopefully in the future, we'll be providing some deeper dives into some of these services, how they work, some tutorials, and again, some of the things that we find most interesting or intriguing in the AWS landscape. But all of that to say, thank you guys so much for watching. Really looking forward to pushing out more content like this going forward, and stay tuned.